Logarithmic functions, one of the topic from calculus, and the topics we'll be covering here is the definition, graph of the function, basic properties of log, and questions based on the properties of logarithmic functions. So we start with the basic definition. If b is positive value and b cannot be 1, means b is any real number, but it should be positive and other than 1. The logarithmic of x to the base b is the function y is equal to log of x to the base b. We write it like this: y is equal to log base b of x, and this actually means is b to the power y is equals to x, which is an exponential function. It's always useful for us to think of a logarithm as an exponent. Reason being, we are pretty much comfortable with exponent function. That is why we generally want to discuss the properties and the graphs in comparison with the exponential function. It makes us easy to understand log. So in words we write it as, here y is logarithm to the base b of x, and here we write it as y is exponent to the base b that gives us x. So check the link, logarithm is replaced by exponent, to the base b is same, and here to the base b of x, and here to the base b that gives us x. Also y is equals to log x base b is defined only for x positive. Reason behind is this is convertible as b to the power y is equals to x, and b to the power y is positive for all y. So it has to be positive because b to the power y is x. X has to be positive. So domain is always for positive values. Log is not defined for negative values. Positive real numbers are the domain for log. Also, regarding the graph of the function, when we plot the graph is continuous and increasing function. It passes through the point 1, 0 on x-axis, because when we take value of x as 1, log 1 base b is 0. The function is continuous and increasing, and function graph lies entirely to the right of y-axis. Why so? Because it is defined for only positive values of x. So the graph will be on the right of y. The next is basic properties of logarithmic functions. Here for the properties we are assuming that b is positive and b can't be 1. The first one is equality rule, which states that log of x base b is equal to log of y base b. This is possible if and only if x is equals to y. Inequality rule, if x is greater than y and b greater than 1, then log of x base b is always greater than log of y base b. Next is product rule. Log of product of xy base b is equal to log of x base b plus log of y base b. Quotient rule. Log of x upon y base b is equal to log of x base b minus log of y base b. Power rule. Log of x to the power p base b is equals to p into log of x base b. This is true for all real numbers of p. Inversion rule. B to the power log of x base b is equal to x, and log of b to the power x base b is equals to x. Interchangeable, both the things. And we have special values as log b base b is 1, log 1 base b is 0 always. The next is two applications are there. One is evaluating a log expression and another is solving a log equation. The first one is suppose evaluating log of 1 by 8 base 2 plus log of 128 base 2. So we are applying product rule here. 1 by 8 into 128 will give us 16. 16 we can write it as 2 to the power 4. Applying the power rule, 4 into 1, 4 is the answer. Solving equation containing log. We need to consider here that log is defined for positive values only. So whenever there is an equation to solve, we have some restrictions that the values on which log is defined has to be positive. 2x plus 1 here, x minus 3 here, both should be positive. So whatever answer we are receiving, answer must satisfy these restrictions. So in left hand side we have applied the power rule on the second term, and then we have applied quotient rule. Solving by a definition, log will convert into exponential, and then solving via normal quadratic equation, factorization. Nine x square minus 56x plus 80. This will provide us the factors x minus 4 and 9x minus 20, which gives x is equals to 4 and 20 by 9. So 20 by 9 is not feasible as the restriction x minus 3 is not positive for x is equals to 20 by 9. This becomes negative. So the only possibility here is x is equals to 4, which satisfy both the restrictions. So x is equals to 4 is the only solution for this equation. Next, I have given some questions for practice. The first two are for evaluation. Evaluate the log expression. And two more questions are there for solving the expression containing log. Kindly comment these answers. And thank you for watching.